So now I'm going to talk about our plans for our user program during the dark period. It's not entirely going away, but it will change in some fundamental ways. And so what we want to do is to, we will definitely collect some information and put on our website our plans for the down and direct them to resources at other synchrotrons for experiments and tell them, give some recommendations of where the best places to do various kinds of experiments will be, and you can apply for time on your own. But we have also made arrangements with SSRL, McChess, and Thomas Weiss is here, and Richard Gillian, and they can, if I tell any lies, they can correct me. And so the plan is to run part of our user program and their beamlines during the dark period, and I'll tell you in a few minutes how we plan to do that. So one of the things we're going to do, we want to do is to have BioCAT staff make a number of trips to these facilities, help do specific kinds of experiments, and then work with beamline staff remotely in other different kinds of experiments. And so how's that actually going to work? And so what we'll also do is that we do have the ability to do non-X-ray experiments at Argonne. We'll still be able to do these, like including SEC-MALS experiments. And we've been doing that for some people behind. That's one of the services we provide. We can start doing these things. And the other thing we will do for experiments where we're not going to the other facilities, we will help coordinate and plan the experiments and help users analyze the data after the fact. And so this will reduce the burden on the staff. And so a lot of the experiments that we plan to send to other places will be very much a cooperative and activity, and you'll still be our users, and we'll still take care of you. So one of the more challenging aspects is to do muscle experiments at other places because nobody's been doing muscle experiments at other places. And so we will be doing experiments in Richard's beamline and McChess in May. If these are successful, our goal is to have at least 3 weeks of muscle running during the down year. That might be 6 individual user experiments. Time-resolved experiments would be possible. They have a smaller version of our Eiger detector that's in vacuum and have the same things. They have an animal facility on campus because Chess is on the Cornell campus. And so with a little bit of work, experiments with live animals might be possible, but those require a lot of procedural infrastructure to happen. A limitation with this beamline is relatively short camera lengths, 1.7 meter max, but with a high resolution detector and appropriate design of experiments, quite a few things we believe will be able to be done then. We'll know more in May. In any case, but that doesn't affect SAC so much. But what about equilibrium SACs experiments? We will, run SEC-MALS SACs, we do it more routinely than Richard does. And so we have proposed 3 one-week runs where we do these, and BioCAT staff will go there and help run user experiments and help Richard develop his SEC-MALS capabilities a little bit more. For ordinary SEC-SACs experiments, people will apply for time in the CHESS proposal system, but they will indicate BioCAT in their proposals, because one thing the other facilities want to do is to show to NIH that they're helping the APS by providing user access during the dark period. And this allows them to do this, get some brownie points from these things. We are also considering having additional mail-in runs where we collect user experiments and BioCAT staff to do those and give Richard, I'm sure, not a well-needed break on occasion. Right here is a link to a facility description talk given by Richard of the SAC-SIG that tells you the capabilities of SAC-SIG. And there's a how-to for applying to this beam time. We can either, we can provide a PowerPoint, a PDF of these talks afterwards, and you can pull these things off that. So we also have talked to Greg Hira at Sybil's, and so they have a very highly automated beamline, and so they have a high throughput mode using 96 well plates, and they can and do the whole plate in 1.5 hours or so. They have sec sacks. They can have 6 columns running once with 6 different running buffers and 12 samples users per week. And so that's another mode they have. And so they think they can have 16 to 24 projects per week of light. So one thing that's interesting is that they don't encourage outside users to come as much as the rest of us do. So they propose to do the experiments themselves, and they feel they have the capacity to absorb quite almost as many high throughput SACS projects and SACS experiments as that we can send them as mail-in experiments. But what they don't have the capacity for is for user support before and after the experiments, and that's what we will provide. We will probably make a trip to ALS and see how things are done and work out some details. Then we can come back and we can consult with prospective users on how to design their experiments and help them with data analysis interpretation afterwards. And so we've also made arrangements with Thomas Weiss at SSRL. We want to do some trial muscle diffraction experiments in June or July of this year. They have a longer ability to do longer cameras, so I'm pretty sure these will be successful. And SRL has a history of doing fiber diffraction experiments on BL42, and so this will not be a big adjustment for them. They have both the Pilatus 1M and a large area MAR detector, which will be so we'll be able to do both static and time resolved experiments with good spatial resolution. They also have a Niger 1M, which is interesting. It'd be quite a bit smaller. They can get quite reasonable fluxes when they use the multilayer mono in excess of 10 to 12 photons per second. So they won't be as good as 18ID for time resolved experiments, but some will be possible. The ability to go to 3.5 meter camera will allow us to equivalent resolution as we have, and so we expect that we're quite confident we'll be able to do muscle experiments. The one downside here is there's no animal facility at SSRL. Equilibrium SACS experiments, we expect maybe 6 1-week runs for SECMOL SACS. Staff we come there and provide assistance to outrun user experiments. People that are only interested in fairly ordinary SECS experiments apply for time in the SSRL proposal system. They will indicate BioCAT in their proposals, so they're counted as SSRL's contribution to the mitigating the dark period. We can, again, they have the ability to do mail-in or remote SSRL through their proposal system. They can have a batch capability. BioCAT staff will help out. They'll be available remotely for help with data analysis and help planning the experiments to reduce the burden on SSRL staff. And they do have some basic robotic sample manipulations and simple robotics experiments that could be used for some specialized experiments. And so you encourage you to talk to Thomas and other BSL-42 staff to see what's possible. And again, we have a facility link, and we have some how-to information that I can point you towards. So time resolved SACS, this will be much curtailed, but the LIX beamline NSS2 has a suitable microbeam optics, and they will be able to do continuous flow SACS experiments. They have proposed a development technique and haven't done this yet. And so what we will do is plan to put in some beam time proposals LIX to do runs in collaboration with Lin Yang there, and we will collect a suitable user experiments, and we might have 2 to 3 such runs during the down year. And so that's the plan. And so during the down year of the I think the equilibrium SACS program there will be plenty of time, and so people will be able to get their projects done. The time resolved SACS will be a little bit more limited, and there will be a quite significant reduction in the amount of time that we can devote to muscle experiments, but important ones that can't wait can be done this way. Now, so I would encourage the muscle program to try and get their time resolved experiments done before the dark period and try and stage developments appropriately. The experiments that would be most feasible at chess and SSRL will be ones where you can send frozen tissue or glycinated skin, muscle, and ice be doing these things that live animal facilities may or may not be possible at McChess. And so we should, again, people that have that as an important part of the scientific program should try and schedule that ahead of time. And so that's our plan. And we're certainly interested in other suggestions in terms of how we can take care of you in the upcoming down period. So thank you, folks.
All right, so we'd scheduled basically a Q&A for the rest of the remaining time, nominally till 2:30, but of course we can end early. But please, if you have questions, feel free to either unmute yourself and ask them or ask them in the chat and we will answer them.
Tom, I think a number of years ago, I remember that Lin Yang at NSLS2 was proposing doing scanning microbeam SACS experiments. And I noticed that that's something that you guys are going to be working on because of your future nice small beam you can get. Do you know what the status of that is? And if there's any, you could take advantage of that somehow?
Well, actually they do it, but not, they've built it and the users haven't come to a very large extent. The problem, we have much the same problem we have. We've actually got quite mature capabilities, and we've put a lot of work into the diffraction imaging component of a muscle X. So we actually, what was slowing down development of the community was having good analysis tools. We have that now. And we've told Lynn about it and we made it available to, Lee Mikowski has done experiments on amyloids at LIX, but I think he did it. I'm not sure how he analyzes data, did homegrown stuff. I mean, we pointed this out to it. So I think the really important barrier in the past was the analysis tools. Both of our lean lines have had the technical capability to do it for quite some time. And
interestingly enough, to jump in here, Richard, I saw a paper published about, I think a week or two ago. I just put a link in the chat from Lynn's Beamline on their scanning mapping programs. So
actually, if I can chime in there as well, there was a paper recently on myelin, actually on myelin and mouse brain, and there was a collaboration. Actually, it was actually run by a guy originally from the Swiss Light Source, where they do this on a more regular basis.
Yeah, they've been doing that for a long time.
Exactly, and so he actually moved to Stanford, and then he was doing actually experiments at NSLS2 and at SSRL and at the Swiss Light Source. And there was like, I think about a year ago, it was like a paper coming out on that.
So there's a huge unmet opportunity there. Now, do we really need to have a lot more people doing a new thing? We're having no trouble at all filling our time at the moment. But the, you hate to see unmet scientific opportunities. Like it'd be nice to do that for important experiments. And so at this point, we'll see how the chips fall. Things come and go.
Hey guys, thanks for having this. I wanted to ask a question about, the power. I come in with the intact muscles. We have been hitting them with a fairly high power, but I'm wondering, with the smaller beam size, do you think that means that we will get more output from every muscle for the fiber experiments, or are we going to basically burn out the muscles in the same kind of the same rate?
You want me to answer?
Yeah, well, you can go ahead.
So we are talking about the things we could achieve with our optim. We can basically we can focus the beam whatever side works for us. So we don't need to go all the way to 20, 30 times more fluxing density if we hurt the muscle.
Yeah, you can always defocus. and you can always attenuate, and you can always slit. So having more flux is never a problem, because you can always just get as much beam as you need.
Yes. And for your experiment, we can do is everything horizontally, so everything's will be much easier.
Thanks, guys.
Hello. Is there any risk of delays, or what do you think about things like that?
Hear me?
I think you're asking about delays in the starting back up of the.
Yeah,
Yeah, that's
in all these projects.
So the APS would like to claim that there is very little risk of that, but we remain slightly skeptical. It will also take after initial turn on, after April 2024. The APS anticipates it'll take a month or two to bring all of the beam lines back online. So I have to redo every radiation safety survey and things like this, and there's just limited personnel for that. So there's no clear indication yet where we're going to fall into the queue of when they do the surveys, when we can turn on. But and then we'll need some time to learn how to kind of play with the machine and optimize it. So my guess is sometime summer 2024 is really more realistic for running most experiments at our beam line with any luck. It's not going to be April.
Okay.
It's also likely that even the beam will be stable enough for muscle before it's stable enough for sacs. And that was their experience when the APS first came up. They had to learn to drive it. And so that's probably how we'll start off while we feel things out.
Okay, sounds good.
We're working on some new feedback mechanisms to improve stability on our side, so hopefully we can compensate for some of that and run sacs pretty shortly after the start, but we'll see how it looks.
Okay, thank you.
If not, I'm glad. I hope this was helpful information. If you have any other concerns, please contact us directly. We will post the recording of this workshop on the website, and we will and also PDFs of our slides if you want to have a look at them, especially for the links.
Yeah, we'll make just generally a resource web page on our website in the next month or two with all of this information, and then keep it up to date as we hear more from the APS. So you can look to that if you have questions, or of course contact us directly. We'll send out a link when that's available. So we might as well give people just a minute or two in case anything occurs to them. But if they don't hear anything in the next couple of minutes, we'll wrap up.
We'll wish you adieu. Right. So, no questions.
You said your microbeam you thought was going to get down to 0.5 microns?
That's with the 50 millimeter, 50 centimeter focal length CRL.
Okay, so that's the short focal length.
The 1.8 will probably be, it probably might be around 2 by 2, but it certainly no bigger than 4 by 4.
Mm-hmm. So you can start to think about single cell, imaging there. Yeah, that's nice. Having
it symmetrical will be nice. All sorts of things be easier with symmetrical beams.
I gotta ask, we've got a user who's isolating cell nuclei and as as pellets and doing X-ray analysis of that. And I wonder if if she could get a lot out of being able to hit one with a single beam. They're fixed. I mean, they're not, they're dead and petrified.
Right. I don't know what you'd see.
Well,
Yeah.
she claims she sees the like the interhistone distances or something. There's some chromatin things that they're able to see in their cell pellets. They get little bumps, that stick up above the normal sacs. I have to admit, I'm surprised they saw anything, but they do. So, but
I guess there's plenty of it. So, yeah, I guess that's plausible. Yeah.
I mean, as with any of these microbeam experiments, I think, part of the trick is getting the beam. A large part of the trick is hitting something with the beam, right? Hitting what you intend to hit with the beam. So,
right.
If we get seriously into the micro diffraction with these much smaller beams, that may be our outstanding challenge.
So the 50 micron beam will be more for your muscle kinds of things, right? I mean, are you able to do sacs with that divergence?
No, not with that divergence. No. I mean, you could do wide angle, but no, nothing in the small really.
You can actually resolve the collagen spacings, oddly enough, for the short focal length. I mean, they're a lot clearer with the long, the 1.8 meters here, 1.8 meters CRL. But we bought the 50 centimeter one and set it up, set up a camera, took a few pictures, and then haven't used it since.
Yeah, we have a one that's roughly 1.5. Yeah, longer focal length, certainly longer than 50.
They work quite well for micro diffraction. The tails are a bit nasty for sacs.
Yeah, well, we were able to get, I did a side-by-side comparison because we could move it in and out and convince myself that we were getting equivalent, more or less equivalent quality, when we used the proper guard slits and stuff. But ours is pretty long focal length, so it's not a big gain. We can't really, we're not a microbeam station, so we can't really get too tiny. Envy your beam.
Yes, we'll have a world-class source for sure. So,
yep.
The future is bright.
Indeed.
All right. Well, if there aren't any other questions, we may draw this to a close. But we're happy to stick around and chat. We always enjoy chatting with folks, but no need to keep everybody on at this point. So I think I'll stop.
So thanks for coming, everybody. And again, if you want to hang around and say hello, please do. But otherwise, thanks for coming.